Questions from the homework? Yes, ma'am. 5-3. Shh. 52, 53. All right, we'll do 52 first because it comes first, even though it's essay. Traveling downstream. Angelo's kayak. Oh, we have a story. Angelo's kayak travels 14 kilometers per hour in still water. If the river's current flows at a rate of 2 kilometers per hour, how long will it take him to travel 20 kilometers downstream? Okay, a couple of pieces of terminology in here that they want you to know. Okay, you got a guy in his boat. Let's say this is the boat. Oh, I'm so artistic and stick figure now. Woo-hoo. Okay, so if we're going downstream, what does that mean to you? Okay, going downstream. If you're going downstream, what? So the current is pushing you along, right? You don't have to work harder, right? So this is like those moving sidewalks over at the airport. Remember, those were the places where it became like a daycare for your parents if they had a late flight and you're a little kid. Go to the airport, you'll see it's daycare. The parents are like, go play on the moving sidewalk. And then there's always some kid who falls. So the moving sidewalk, as you walk on it in the direction that it's going, you're not working any harder, but you look to your side and go, man, you're really moving pretty quick. So then you might try to walk fast to see how fast things really are moving by you. And then you might be the kid like me who wants to go the other way and go upstream, so you have to go faster than the sidewalk itself is moving in order to advance yourself. And then you also might be like me and be that guy that says, wouldn't it be funny if two guys were running at the same time and the other one sticks his arm out and clotheslines the other? If they're going, that might be just me. All right. So Angelo's kayak travels 14 kilometers, and so I know I have distance is equal to rate times time. Are we okay with that? That's one of those equations that you've probably seen since 4th grade. Travels 14 kilometers in still water. If the river's flowing at 2 kilometers per hour and he's going with the river, how fast is he really going? If his kayak can do 14 kilometers per hour and the river is doing 2 kilometers an hour, how fast is he really doing to the guy who's standing on shore going, wow, he's paddling fast? 28? Or, you multiply it that way. So his boat does 14 kilometers per hour, and the river does 2 kilometers per hour, and you're both traveling in the same direction. So how fast are you really going? It's not 28. 16. So his rate, because of him and the river, he's doing 16 kilometers per hour. Okay? Time will then be in hours. And that says, how long will it take him to travel 20 kilometers downstream? Okay? So that's basically how the problem's set up. Now we have everything labeled, which makes it way too confusing to look at. So things that we probably could do is we could realize that the hours are going to cancel each other out. If I solve this, I goofed up, didn't I? No. Why did I goof up? Oh, I know what I did. So I'm not going to do that. Undo. So I'm just going to do 20 is equal to 16 times x. So how long is it going to take him to travel that distance? How much? 1.25, and you would have gotten that by dividing both sides by 16. Thank you. So 1.25 hours on the river. And the reason I couldn't cancel the hours out is because I had an unknown on the hours. And then 53 was the next one we wanted to look at. Looks like we have another story that we need to generate a picture. It says, flying into a headwind. Okay, an airplane that travels 450 miles per hour in still air encounters a 30 mile per hour headwind. How long will it take the plane to travel 1,050 miles into the wind? So what is a headwind? Do what? Yeah, wind's pushing against you. There's my airplane. Let's pretend I'm a great artist. This airplane is maximum miles per hour, does 450 miles per hour. Okay? And that's in still air. If you have a tailwind and it's pushing you along, you're actually traveling faster than that, which is good. But you're on that flight and you just want to get home a little quicker. Well, now you have a force working against you called a headwind. And this headwind is doing 30 miles per hour against you. Okay? So is the plane doing 450 miles an hour? If the guy's sitting there on the ground going, oh, look, this is how fast the plane's going. It's going 420 miles per hour. Because you have a force working against you, it's doing 420 miles per hour. And then it says, hey, how long is it going to take this airplane to travel 1,050 miles? So we have distance is equal to rate times time. We have a distance of 1,050. We have a rate of 420. We have time that's unknown. We'll call it x. Divide each side by 420. What do I get? Anybody? So I want to go 1,050 divided by 420. How much? I keep hearing answers, but I don't hear it clearly. 2 point something. All right, here we go. We got TI-84 coming up. 1,050 divided by 420. 2.5 hours. Sounds good. So that airplane is going to take 2.5 hours to travel that distance when we... Okay. Any other questions from the homework? Go once. Yes. 43 and 44. Shh. Okay. Test plot dimensions. Ooh, another story we have here. Morgan's Seeds has a rectangular test plot with a perimeter of 322 meters. The length is 25 meters more than the width. Find the dimensions of the plot. Okay? So, things that I know is I'm dealing with a rectangle. Okay? So if I'm dealing with this rectangle, there was a problem that was on the test that dealt with the garage and a pen, right? Does this have a garage? That's one of the sides. What do you think? No. All right? So just labeling a rectangle, I know I have a length here, I have a length here, I have a width here, a width here. Okay? Can the width be longer than the length? Absolutely. It's just we've all been indoctrinated to understand rectangles. You have length and width, and length is the longest side. It doesn't have to be though. All right, so this is problem 43. So they tell us that we have a perimeter. We have a perimeter of 322 meters. And then we have a relationship between the length and the width. Good catch. So I'm going to call the length and the width. They tell us that the length is 25 more than the width. So if the width is referred to as x, how would I refer to the length in terms of x if we know that x plus 25? Good. Okay? And then other things I want you to remember about this problem is the perimeter equation, which you learned a long time ago. Is the perimeter of a rectangle is 2 times the length plus 2 times the width. Is that okay so far? We know our relationships as far as algebra goes, as far as the x's. And we know the perimeter. So I have 322 is equal to 2 times the length. We know the length is now not going to be L, it's going to be x plus 25. We know the width to be x. Okay, distribute here. So I got 322 equals 2x plus 50 plus 2x. So that's going to be 4x plus 50. Subtract the 50. All right, so I'm going to get 320 minus the 50. Is that what it was? So that gives me 270. We're going to divide that by 4. So we find that our x value is 67.5. And so they ask us this. Find the dimension of the plot. X was which letter? Too much talking going on. Back in the left corner. Normally don't get that much talking. What's X? Width or length? Width. Okay. So this is 67.5 meters. And I know that's an M, supposedly. And the length is 25 more than that. So if I add 25 to 67.5, what do I get? Anyone doing it? Or are you just staring? How much? Okay. So 5 and 7 is 12. Carry the 1. It's 8, 9. 92.5 meters. So if I add 92.5, 92.5, 67.5, 67.5, I'll get my perimeter of 322. What was the other question you'd asked? 44. Garden dimensions, another story here. Number 44. The children at Tiny Tots Daycare plant a rectangular vegetable garden with a perimeter of 39 meters. The length is twice the width. Find the dimensions of the garden. Okay? So this daycare center has created themselves a garden, and just to screw you up, we'll change the length and width. All right, we know that the perimeter is 39 meters, and then they tell us other things about this. They say the length is twice the width. So if the width is x, what is the length in relationship to x? 2x. So I know the perimeter equation is 2L plus 2W. Let's put in what we know. We have 39 is equal to 2L, which is 2x. We know that W is x. So we'll solve it. So that's 6x is equal to 39. So 39 divided by 6. How much? 6.5. So this is 6.5. Twice that is going to be 13. So the length is 13. The width is 6.5, even though I labeled it backwards. I don't care. Anything else? All right. Make sure your name's on the assignment. If you didn't get it done, get it done. And pass it around this way, please. While you're sitting there, if you have the graphing calculator, get it out, please. Thank you. All right. All right. So we're going to start talking about a little bit about radicals, and radicals are square root. All right, in a radical, you can have a square root, you can have a third root, you can have a fourth root, so on and so forth. So, starting out pretty simple, I think you all can tell me the answer to that would be 4. But then, things got goofy in Algebra 1, and they did something to where you got 2 answers. And the reason you got 2 answers is you might have had a problem given like this, and what do you have to do to both sides in order to get x alone? take the square root. And if I take the square root of both sides, this is going to give me an answer of plus or minus 4. So if you do a mathematical operation to get a variable by itself, and it's a square root, you have two answers. But if I ask you what is the square root of just a number, it's a singleton answer. Okay? Now things that could work with this problem, we could generate a little bit further, is we could say, what would happen if I had negative square root of 16? What would my answer be? Negative 4. And then they got into what would happen if I had negative under the square root sign. And some of you are like, oh, it doesn't exist. It doesn't work on my calculator, which you're correct. But this is a different number system. It's called the complex number system. The complex number system defines a lot of things in math that didn't work out. Okay? Complex number defines a lot of things that didn't work out. Okay? So you can indeed have the square root of 16. You have to recognize if you have a negative under the radical, you're going to generate an I out front, and then you take the square root of 16. So my answer here is going to be 4i. So I is introduced to something called an imaginary number. An imaginary number doesn't mean like you're using your imagination. That was the name that was given to it. It's part of something called the complex number system. And when you start talking about number systems, this is back when you're in kindergarten going, okay, you're counting numbers, then you have your whole numbers. And they're trying to define to you that the difference between the counting numbers and the whole numbers is the whole numbers include 0, and the counting numbers don't. And you back then were probably going, who cares? And you're probably right. And then you started talking about the integers, and the integers were different. And then the integers built into rational numbers. And then you had things that were irrational numbers. And irrational numbers and rational numbers didn't make any sense because no one really explained it correctly. But the difference between rational numbers and irrational numbers is this. A rational number, no matter what the decimal is, can be written as a fraction. An irrational number cannot be written as a fraction. Okay? So an idea of an irrational number is if you were to take pi, which is 3.14159, and it keeps going forever, it doesn't repeat, doesn't have a pattern to it. So being it doesn't repeat, doesn't have a pattern, continues forever, you cannot make it into a fraction. Now, you might have had some teacher that told you, 22 over 7 is about pi, and so you think you found the fraction, way back when. No, you didn't. You found an approximation to it, but the fraction pi cannot be written, so it's called an irrational number. Other numbers that are irrational would be like the square root of 2 or the square root of 3. Okay, the square root of 5, things like that. Those are all irrational numbers. So any number that you couldn't write as a fraction is what an irrational number would be. Rational is everything else. And those are two other number systems. And then you put all of that into something called the real numbers. And the real numbers is everything that was rational, irrational, counting, integers, positives, negatives, fractions, all of the good stuff. And then you got to a point where you didn't allow something to have a square root of a negative, and that fell into something called the complex numbers, and it's actually called an imaginary number. An imaginary number is a portion of the complex numbers. The complex numbers encompasses all of the number systems that you have ever dealt with, including having the square root of a negative. Okay? Now I've bored you guys to tears, so let's move on. All right? So, square root of negative 1 is equal to I. Okay? So, examples for this, if you had the square root of negative 7, you could rewrite this as I root 7. If you had the square root of, say, negative 8, you could turn this into 2I root 2. The reason that works that way is you see where the I comes from, but that breaks down to 4 times 2. And then there was other situations where you might have actually had this, and this would come out to 4I. So there's different scenarios that could take place. When you have a negative under the radical, you are getting answers out of each. So I said I I is equal to the square root of negative 1. I squared. If I were to take negative 1 as a square root, now if I were to square the square root, what happens to the two? They cancel. So I squared means I'm just going to take this right here and square it, which means I'm going to get an answer of negative 1. And then you have I to the third, which is like saying negative, or square root negative 1 times root negative 1 times root negative 1, which is the same thing as root negative 1 times root negative 1, which is the same thing as taking I and negative 1 and multiplying them together, so you get negative I out of it. And then I to the fourth is the same thing as taking I squared and multiplying it by itself. So I squared times I squared. Well, I just defined that I squared is equal to negative 1. So what is negative 1 times negative 1? 1. It repeats after this. It goes back. I to the fifth is equal to I to the sixth is equal to whatever I squared is, which is equal to negative 1. I to the seventh is equal to negative I to the eighth is equal to 1. Repeats. So it repeats every 4. So on the SAT or the ACT, you might come across a problem that says, what is I to the 34th power equal to? And you're like, how in the heck am I supposed to know? Okay? Easiest way to do this is you just really need to recognize I repeats every 4. So if it repeats every 4, do this. Take this and go 4 into 34. Still with me? How many times does 4 go into 34? 8 times? So I get 32. What's my remainder then? 2. So I to the 34th is the same thing as I squared. I squared is the same thing as what? Negative 1. That might be that aha moment of, darn it, I wish I would have known that when I took the ACT as a junior. Or if you're a junior right now, be ready to always put an I to a higher exponent on the ACT. And most kids that haven't had that just blow right past it, make their best guess. The unfortunate thing is on the ACT, they'll have the answer of I, or they'll have the answer of square root negative 1, they'll have square root negative 1, negative I, 1, and then they'll have some completely obscure answer that doesn't make any sense to the problem. And a lot of people take totally obscure answer for their problem. So with that known, what would I to the 15th be equal to? What's I to the 15th equal to? Let's see, 4 goes into 15 3 times. What do you have left over? So you have I to the third, and what would we say I to the third is equal to? Negative I. Perfect. Okay? So you always divide by 4 because it repeats. Whatever your remainder is will relate back to I squared, I to the third, I to the fourth, put the equivalent value to that. Now, somewhere back then, they decided, well, shoot, if we can add, subtract, multiply, and divide all of our number systems, can we add, subtract, multiply, and divide our complex number systems? What do you think? Can we add, subtract, multiply, and divide our complex number system? Absolutely. So a more complex number, you might have 3 plus 2i, and we might want to add that to 7 plus 5i. Okay? 2 complex numbers add together. Simplest thing in the world to do. Okay? 3 and 7 add together give me 10. 2i and 5i add together to give me 7i. Problem's done. Okay? Just adding like terms. I, for the most part, will act like a variable, but it's not a variable. It does stand for something. I stands for the square root of negative 1. Okay? If you were to subtract them, let's say you had 5 plus 2i minus 7 minus 3i. Do what you normally do. Distribute your negative to both things. So I get 5 plus 2i. I can drop the parentheses. minus 7 plus 3i. Combine like terms, 5 and negative 7 is negative 2. 2i and 3i is 5i. Problem's done. You can also use your distributor property over this. So let's say you had 3i times 4 plus 2i. Distribute. 3 times 4 is 12. I comes along for the ride. 3 times 2i, that's 6i squared. What did we say I squared was equal to? Negative 1. So what is 6i squared, or 6i squared equal to? Negative 6. So I get 12i minus 6. Problem's done. I can't combine the 12i and the negative 6 together. Yeah.
So if we were to leave it as I squared, like on a test or something, would that be wrong?
Yeah. Yeah. That would probably be a 3-point problem. If you left it as I squared, I'll take 1 point off of the 3. Is that right? Yeah. Okay. So we can add, subtract, we can multiply. You can multiply it in the form of FOIL. So if you had 3 plus 2i and 6 minus 3i, and you wanted to use the 4-letter F word in math called FOIL. FOIL this, I'm going to get 18. Then I get the outside, minus 9i. Inside plus 12i. Plus. And then last is going to be negative 6i squared. I can combine those together, so I'm going to get 18 plus 3i. What is negative 6i squared going to be equal to? Plus 6. Do I have like terms again? 18 and 6 combined together give me 24 plus 3i. So the FOILing works nicely. When you just have I, that's great. Leave it as the I. You get I squared, turn it into a negative. So it's basically multiplying that number times a negative 1. And then let's talk about the divide. So a long time ago, some meeting the math community had said we don't want to have I in the denominator. And it's like this no-no for some reason. It actually has to do with prior to having calculators, why it became a big no-no. But if you wanted to get I out of the denominator and it's just as a singleton, it's pretty simple to do. You just put that in parentheses and multiply the top and bottom by I. Make sure you distribute on top, so I get 2i plus 3i squared. On bottom, you get 6i squared. What is I squared equal to? Negative 1. What's 3i squared equal to? Negative 3. What's 6i squared equal to? Negative 6. I guess you could flip-flop it to look like this. Negative 3 plus 2i over negative 6. I would really accept either answer. And then there's times you might have I in the denominator that comes as a binomial. Am I going too quick? Yes? Slowing down? It's the loudest conversation going down our hallway. All right, ready? 5 plus 2i on top, 3 minus 7i on bottom. Okay, you just can't multiply top and bottom by I right now. If I multiplied the bottom by I, I'd get 3i minus 7i squared, or 3i plus 7. So I still have an I in the denominator. So there's got to be a different way to go through and get rid of the I from the denominator. So what we're going to do is we're going to multiply both top and bottom by the conjugate of the denominator. No, we're not in French and Spanish. We're not conjugating. The conjugate, which is a binomial which has one opposite sign. So I'm going to multiply the top and bottom by the conjugate of the denominator. I'm going to put everything in parentheses. That's my first move. Everyone should be okay there. Just grouping things. And then I'm going to take the conjugate of the denominator and multiply both top and bottom. So the conjugate of the bottom is 3 plus 7i. And multiply that on top as well. Is that okay so far? If I multiply the top and bottom by I, this would be 3i. So I didn't eliminate the I from the denominator. So if it comes as a binomial, meaning two terms. Yo! Every little. If I multiply top and bottom by the conjugate, I'm going to FOIL the top, which is going to give me 15 plus 35i plus 6i plus 14i squared. We'll work that out in a moment. The denominator, FOIL it out. I get 9 plus 21i minus 21i minus 49i squared. I have like terms here and here that I'll take care of. What's 14i squared? Negative 14. On bottom, the 21s cancel each other out. What's negative 49i squared?
49.
Positive 49. All right, so let's bring that up. So combine the like terms on top. 15 minus 14 is 1 plus 9i. On bottom, combine like terms. I'm going to get 58. And there's my answer. You doing okay? Can you last time for me? Can you give me one last thing? So with the calculator is going to do some stuff. One last thing, this will be done on the calculator. So the calculator, they were nice. They said, hey, let's create complex numbers. So you could go under mode and turn up to the a plus bi. I would say don't do that under mode, okay? Even though I just said don't do it. The calculator will do everything that we're going to do, still staying as real numbers, not as complex numbers. So let's go through it. So let's on the calculator go with 3 plus, let's go simple, 3 plus 2i. We're going to add that to 5 minus 7i. Okay? I know that I just taught you how to do it longhand. It's pretty easy to do longhand. Let's bring the calculator out and take a look what it's going to do. All right. All right, 3 plus 2i. Pretty simple to do. 3 plus 2i, plug it in the calculator. Use the parentheses. Go with me. 3 plus 2. Now we have to find the I. Does anyone see the I that is not the alphabet I on the calculator? It's the dot. Okay, so I have to do the second of the dot. Okay? Close the parentheses, and then add that to 5 minus 7i. So in parentheses, 5 minus 7. And again, this is going to be my I. Close the parentheses. You get enter from there. It's going to add things together. So 3 plus 5 is 8. 2 minus 7i is 5i. Problem's done. It's the decimal next to the 0, so it's the second of that. Find it? Everyone else find it? All right, what if we had this? Will the calculator do it? No. I hope so. So make sure we're going to group it. If it's not grouped on the problem, group it on your homework and when you put it in your calculator. When I say group it, what does that mean? Put in parentheses. I'm going to clear out what we got here. So I have parentheses 4 plus 2i. Close the parentheses. And then I'm going to go divided by. Being it's grouped, I don't have to worry about if it's going to do the problem right or not. 6 plus 3i. You got 2/3 exactly. Yeah? I have no idea what the answer is. Good answer? Ooh. Yeah. Hey, does anybody know this key on their calculator? It's a decimal. How do I make it a fraction?
Math.
Math. action. Enter. Whoa.
Error. You messed up.
Okay. So I'm just going to do this real quick. I know what the answer is supposed to be. Math. Enter. There it goes. All right. Someone say they lost? We good? All right. Here comes your assignment for next time. Hey, did you guys have a good day off yesterday?
Yes.
Anyone have to show up here? I tell you, if we had Tuesdays off every day, every week, that might be an all right thing.
Was it fun? Yeah, no, you never have to do this. You have, even for the school ones, that you can bring it up to
There you go. Yo. May it stop.